Geometry Chapter 10, Lesson 5, and we looked at determining the area of regular polygons using trigonometry. We want to look at one other way that we can use trigonometry, and that is going back to determining the area of a triangle. Now you remember from earlier lessons that the area of a triangle can be determined by taking 1/2 the base times the height. Well, in this situation the height is not given, and so what do? Well, actually, if we were to draw our own height using this side as our base, and we drew our height down here, this creates a right triangle over here, and we could use trigonometry because opposite this angle, and then this is the hypotenuse, we could use the sine ratio. So the sine ratio would give us the height. So the sine of 28 would be h over 34, and solving that for h, we get 34 sine 28 as our value for h, which would be our height. So then we could simply take that value and substitute it in our formula. 1/2 the base, 39, times the height, excuse me, times the height, which we calculated at 34 sine 28. And doing this leads us to a way that we can rewrite this formula because it always works out the same way. In other words, if we look at what we just substituted in, the 39 is a side that's given, the 34 is the other side that's given, and the 28 is the angle that's given. Well, this leads into this formula right here where the area of a triangle is no longer 1/2 base times height, but this c sine a takes the place of the h because the c sine a is trigonometry used to figure out the height. So this different formula, 1/2 b c sine a, the b is simply a side of the triangle, the c is simply another side of the triangle, and the a is the angle that's in between those two sides. Now that is the caveat, and the caveat means the exception, or the thing you have to be aware of, is that this will only work if the angle that's given is between the two sides that are given. And in this book that will be the case for all of them, so you won't have to worry about it. So what you're given here is another formula for the area of a triangle. And how do you know when you want to use this? Well, you'll want to use this formula when you're given an angle and you're given two sides. Otherwise, you'll probably want to go with 1/2 BH, but both of them will give you the area of a triangle. So very quickly, let's do this with a couple of examples. On number 11 here, the area is equal to 1/2 BC sine of A, and the reason I want to use that is because I'm given an angle measurement and the lengths of two sides, and I don't know a base and a height. I don't have any perpendicular segments. So when you look at a triangle and you don't have any perpendicular segments drawn, that's a good indication you might want to go this way with it. So 1/2 B can be either side, it doesn't matter. So we can put the 11 in if we want. C is the other side, which would be the 6. And then the sine of the angle would be 57. So this is all multiplication, so I can take half of the 6 would be 3, and then 3 times 11 would be 33, and so I have 33 times the sine of 57. So then I can go ahead and put that in my calculator. 33 sine 57, and that gives me an area, see, it sounds to the nearest tenth. So doing my rounding procedure, I'm going from exact to estimate. So this is about 27.67, which then is about 27.7, and then I'm going to have meters squared for my area. And we can double check our answer, 27.7 meters squared. Okay, so 1/2 BC sine of A is another way to calculate the area of a triangle, and you want to use this if you're not given a height and you are given an angle, and then the two sides with the angle being between the two sides.